Hello, everyone. Welcome back to Maths on African Motives. We are still on our Mathematics N6 as we are preparing ourselves for the exams which are ahead of time. So this is a typical exam question that you're going to work with, which is actually our August 2025 exam. That is question number 1. We shall consider this part of our differentiation. So remember, that is our differentiation. So without wasting our time, we were given the first part, which is 1.1. That is the sides x and y of a right-angled triangle. So we are given they are 2 millimeters and 3 millimeters respectively, with the hypotenuse as what? As r. Okay, so taking this into consideration, before we look into our question, they are saying there is a right angled triangle in our case. Okay, it is a right angled triangle. One of the sides is x and another one is y. So you can just name whatever that you want. So you can call this x, this is y, and the hypotenuse is what? The hypotenuse is given as r. So that is our condition, where x is what? 2 millimeters. That is 2 millimeters there. And y is equal to 3 millimeters, as we are given that information respectively. So that is what we are given. That is our information. Calculate the approximate change in what? In the length of the hypotenuse. Remember, our hypotenuse is called r. So the approximate change, the change in this hypotenuse, is the one that we are supposed to determine. We do not know this change, which you can write, some they can write this as dr, the change in that hypotenuse. If x changes to, that is the major part of our statement, it changes to 3 millimeters. X changes to, from this value of x. Our x originally is 2 millimeters. Then it changes. Now it is just like this is x1. Then we've got x2, which is now 3 millimeters. It changed from to this value. In most cases, when we are given this, the applications of our partial derivatives, when we are dealing with partial derivatives on our applications, in most cases, you are given the change that is it that happened for x. They will tell you the change that happened for x. You have that change for x, which we can also just write as the change in x, the change in y, the change in whatever that you're given. But there we are not given that change. No. They told us that x changes to a certain value from to this value. So it's from to this value. So therefore, we can have that change which happened in x. So the change in length in terms of our x is going to be what? x2 minus x1, which is the final 2 to this value. That's our final 3 minus what? Where it started, the original values that you are given, which is 2. So that was going to give us what? 1 millimeter. That is the change that happened in what? In x. 1 millimeter, which is a positive value. So a positive means what? It is an increase that we are referring to. Then we're also going to need the change in y, as also y changes to a certain value. So it is the same thing, just like the previous case. That change in y is going to be determined as y2 minus y1. So that is, it changed to, this is our y2. Originally, this is our y1. So that is going to be 5 minus what? Minus 3, which is 2 millimeters. So that is the change in what? In y, which is 2 millimeters. A positive means it's what? An increase. So as we can see, our X had an increase, Y also had an increase. So meaning to say that is just a positive, okay? A decrease, you represent it with a negative. So the question here is for us to determine the approximate change in length of the hypotenuse. So the change that is going to happen in hypotenuse is, or it must be affected by the two variables that we are given, which is X and Y. So we must have a relationship first. For that change in our R there, it must be from a relationship of R in terms of X and Y. So what is that relationship? That is the one that we need. So you're going to find a relationship. In most cases, you'll be given, but on a right-angled triangle, they are not going to give you this because they expect you to understand the relationship between the hypotenuse and the two shorter sides. Remember, our hypotenuse squared is equal to the what? The square, the sum of the square of the two shorter sides, which is x squared and y squared. The two shorter sides. So thus, we can have our hypotenuse from there, introducing the square root to get rid of the square, just the square root here. So that's simply our R is equal to x squared plus y squared. Remember, the square root simply means to the exponent of a half. So y raising to the exponent of a half. Remember, this is under derivatives. So we are going to differentiate. It is easier when we can properly say the exponent. So that is, this whole function is affected to the exponent of what? 1 over 2. All right, so this is it. We have, in this case, a statement of our R in terms of what? In terms of X. We have that in terms of X and Y. In terms of X and Y. So we have that. So the question is, how can we determine now that change that happened in our hypotenuse? So the change, okay, let's have our statement in that case. The change, remember, it is supposed to be affected by what? These two variables, X and Y. So the first is our R affected to X and also to Y. So that is, let us start with R and X, meaning to say we have got the derivative of R there with respect to X. R with respect to X, our variable there. So this is supposed to be multiplied by the change that happened for what? For X. X changed. Remember here there's a what? A change in X. So we're going to multiply to the change in X. Plus, we do the same. We are still on our R there. It is affected by two variables, remember? X and Y. So we started with X, so it's R and Y this time. So that's the derivative of R with respect to Y times its change for Y. So this is what we have. So meaning to say, there is a need for you to determine these partial derivatives for R with respect to X and R with respect to Y from this statement that we are having here. So let us just try to have our derivatives here. From this R, which is equal to X squared plus Y squared to the exponent of a half. Remember our chain rule. The derivative of R with respect to X. Remember, when you're dealing with a partial derivative, at that moment, you treat the other variable as a constant, meaning to say the y that we are having here is treated as a constant. So the whole part here is a constant, just like 2, just like 3, any number that you can think of. So our focus is to differentiate the part of X. But we cannot just do that direct because of what? This part here that we are having being raised to the exponent of a bracket. So we must consider differentiating, focusing on the exponent. So the exponent first, all right? So you deal with the exponent, so you drop the exponent, the bracket as it is x squared plus y squared, then we subtract a 1. Remember the derivative concept, you drop the exponent, you subtract what? You subtract 1. So meaning to say that is going to give us what? A negative half times the derivative of what is inside of the bracket now, the derivative of what is inside. So it is the outer part, then what is inside the bracket, of which what is inside, we are focused on what? On x. That is where I was saying this y is a constant. So we differentiate this with respect to x. So x, drop your exponent, that's our 2x. Y squared, remember y is a constant, just like 3, just like 4. So its derivative is what? Is a 0. We are considering what? A constant there. So this is it. This is what we have. You can simplify. That one is in your hands. You can just simplify at the end. All right. So here, that is the same. Remember, to the exponent of a negative, we can take that negative. It's going to be 1 over. So that's 1 over 2 is already in the denominator. So we're going to have this one with x squared plus y squared to the exponent of a half. So here we are getting rid of the negative exponent. Okay. Then if we simplify here, 2x plus a 0, that's 2x. So we're going to have 2x, and this can cancel the numerator to the denominator concept. Multiplying the numerator to the numerator, that's 1 times x, which was going to give us what? X over the denominator. Remember, to the exponent of a half, all this was taken from what? The square root of. So you can rewrite as it was before, which is the square root of x squared plus y squared. So just looking into our question, guys, by just looking into this part of x and y, we can see that it is x squared. The other part, it's y squared. So meaning to say, as we are to find the derivative of r with respect to y, we are simply going to have the same presentation, only that on top is going to be y there. All right. So that's another thing to consider, to say, as you are to have that derivative, you know how your answer is going to look like. All right. So anyways, guys, this is it. Our derivative, partial derivative of r with respect to x. So we need of r with respect to y, which I just gonna, all right, let me just try to have it here. So like I said, here we are just going to have same presentation as before. So that is the derivative of r there with respect to y. We treat x this time as a constant from what we are given here. So x is our constant this time, but the idea does not change. We differentiate the outer part of the bracket, which is when you're considering the exponent. That's the outer part. All right. So the outside part, if we are to consider that, we drop the exponent, that's 1 over 2 x squared plus y squared, then we subtract 1. So that's negative 1 over 2 on our exponent. Then we're going to multiply by the derivative of what is inside of our bracket. But considering what? The part of y with respect to y. X is a constant, just like any number that you think of. Is it 2, whatever that you think of. So meaning to say, when we are to differentiate that, it is going to give us a 0 plus the derivative of 2y with respect to y. We can differentiate that, so it's going to be 2y. So that's it. Drop the exponent, subtract 1. So we can simplify just like the previous case, 1 over what to get rid of that negative. So it's 2 into x squared plus y squared to the exponent of a half times 0 times 2y, that's 2y, that's this part, and this one is going to cancel. So that is the same as over 1. So y times 1, that's y over what? The denominator as it is, but we're going to have the square root, therefore, exponent of a half. So that's it. We have the derivative of r with respect to y, the partial derivative, just like what we had for r with respect to x. So this is it. Same presentation. So with these two, we can substitute back. Substitute in place of these two partial derivatives of r with respect to x and r with respect to y into this formula. So there we're going to have the change in our r is equal to what? We have got this. We calculated this. Remember, r with respect to x. So that is what we're going to substitute x over the square root of x squared plus y squared times the change that happened in x. Okay, so for the meantime, let us just write as it is, plus we're gonna need the derivative, partial derivative of r with respect to y, which is this one. We have got the solution, that is substitute there. So that was gonna give us what? Y over what? The square root of x squared plus y squared times this part of the change in y, which is the increase as we calculated before. So that is it, guys. You had to calculate these derivatives aside, then substitute into the formula. After, we can now substitute the values as we are given them to determine the exact change that happened. We are given the original value of x. Our x is what? And these units are same dimensions in millimeters. So our x is 2 and y is what? Y is 3. So x is 2. So that was going to be 2 over the square root of x squared. So that's 2 squared plus, remember that y is 3. So that's 3 squared times the change in x, which is the increase by what? By 1 unit from 2 to 3. Remember, we calculated that one. So it increased by what? By 1 unit. Plus y is given. Remember, y is what? Is 3. And our x is 2. So that's the square root of 2 squared plus 3 squared times the change that happened in y, which is 2 millimeters. An increase, that's a positive. So let's say it was a decrease. You must have a negative value on your answer. All right, so that is it. We can simplify this. This we can simplify separately. That's gonna give us the change in R2. This is 1, guys. So 2 times 1 is gonna be 2 over the square root of 4 plus 9, which is 13. All right, 3 times 2, that's 6. This one is going to be the square root of 13 again. As we can see, guys, the denominators are the same, or just use your calculator. It's up to you. Or you can just add the numerators together. So that's it. 8 over square root of 13. We are done. Or you can write it in exact form. Sorry for that. 8 over the square root of 13. The square root of what? Of 13, like this. So that's 2,219 to 3 decimal places. We can even fix our calculator. press 6, then sorry, I need shift setup, press 6, then press 3 to 3 decimal places. So that's it, 2,219. So that is it, guys. And the units are in what? In millimeters, as we had these other dimensions are in millimeters. So that is what you're going to have in what? In millimeters. So that was the change that happened in the length of the hypotenuse from the given information. So these are simply applications of our partial derivatives. We can have such questions. Yeah, we can have such questions. We just need to work out as many questions as we can. Let us consider 1.2, which is part of our parametric equations. They gave us x with respect to t and y with respect to t in terms of t. All right. Then 1.21, you're asked to find or to determine the derivative of y with respect to x. But we have x as a function of t. How is that possible? How is that possible? Through our parametric equation, we can differentiate this. The derivative, all right, let me have it here. The derivative of y with respect to x from our formula, if let's say we are given x in terms of theta as you are given from the formula sheet, it's going to be dy d theta over the x d theta. But in this case, guys, we are dealing with t instead of what? Of theta, the one that you are used to. So this is dy dt over what? The x dt. Okay, so that's another formula. There is another one that you can write as dy dt times dt dx, dt dx, so that these two cancel. So guys, it's one and the same. So it's up to you which formula are you going to use, but at the end of the day, you are going to have same answers. Okay. And another thing, guys, make sure that you become part of the membership, because we are going to have most of the questions of this question paper on membership. Actually, to do this question paper, it was a request from that membership. Guys, there's a lot of things that we are working on. So let us join membership. And also on that membership, there are a lot of things to be done actually under request. So guys, for those who are under membership, maybe you've got your questions that you've asked and they're not yet done. Oh, guys, let us just be patient. We are still working on those questions, everything. Once we just have time, we'll work on it. We'll actually work on it. So, yeah, that is the most important thing. We're gonna try by all means. Right now, we are just rushing. Issue of time, exams, they are ahead of time. They are ahead of time. So we shall see according to our time. But anyways, that is it, guys. On our our parametric equations, you have got two formulas to consider there. So you choose one of your choice. So as we can see, y with respect to t, there is a part that you're given y with respect to t, y in terms of t. So we can have a derivative from there. X with respect to t, there is x which is given in terms of what? In terms of t. So let us differentiate. If x is equal to t minus t squared, what is the derivative of x with respect to t? All right, so here, guys, this is 1. So it's just going to be 1 minus, drop the exponent, subtract 1. So that was going to be 2t. There is the derivative of what? X with respect to t. There is also y in terms of t, which is the ln of what? Of 3t, a natural logarithm. So from our derivatives, okay, let us go to our formula sheet. Maybe we can just have something. Derivatives, a natural log here. If we are given, this is actually page 2 of our formula sheet, is that so? If we are given E of ax, right? Let's check, is it a linear? Or let's just go back, but it was a linear, that one. It was linear 3t. So that's a linear. If we are given 3t, it's linear, right? It's not 3t squared or 3t cubed when you just take it as a normal function. When it is like that, let's say 3t squared to the exponent of 3, this and that, you take it as ln f of x. This one is the best that you use. Let's say you're asked to differentiate with respect to x, something like the ln of 2x squared plus 3x. When you have got something like that, they are saying you can use this 1 over that function times when it is f of x, like it's a function of f of x. It's just like what can we say? We have gone back to function of a function. So in our case, it was not that much because there is what, 3t. So 3t can be taken as just ax, right? It's a linear. So it's going to be 1 over 3x, which is 1 over 3t. So in our case, it's 1 over 3t times d dx, the derivative with respect, as we are dealing with what? With the t. So it's supposed to be derivative with respect to t of this 3t. So if we differentiate 3t, guys, is what? Is 3. So that is it. So it's going to give us 1 over t, just like that. Or we can just consider, I explained something like this in some of our revisions when I was saying if you're given, the derivative with respect to x, all right, now it's with respect to t, and we've got ln f of t like this. So it is going to be the derivative of f of t over what? F of t. So if it was f of x, it means f of x here, f prime x, f of x. Derivative. Meaning to say the derivative of this is our f of t, f of t. What is its derivative? What is the derivative? A linear, guys. This is a linear function. So it's going to give us 3 over what? F of t, the function as it is, which is 3t. So that is going to give us 1 over t. Oh, just guys, I don't know. I don't know this one. If you just see, okay, the answer there is 1 over t because we're dealing with a linear. Just know, guys, if it is 3x, it's 4x, it's 10x. As long the exponent is 1, is going to give us 1 over that, 1 over x, 1 over x. If it is t, 1 over t, like that. Okay, anyways, I've explained a lot of things that are not necessary for now, but it's revision, guys. We just need all of these things. They are necessary as we are approaching our exams. Okay, so let us combine. As I chose to use this division, I'm just going to combine these two derivatives to obtain the derivative of y with respect to x. So dy dt, I have it. That is 1 over t. So that is 1 over t. All right, so we've got 1 over t there. Everything over what? Okay, I have to put a bracket here because it's a single fraction. I'm treating this as a single term. Okay, dx dt, I also have this one, dx dt, which is what? 1 minus 2t. So this is it. Okay, remember I referred to a over b over c. All right, over c like this. A fraction to a certain number in the denominator, you just have to a over bc. These denominators, they combine, remember? So this denominator is just going to combine this denominator. So that's in simpler terms. If you do not want to have a lot of things, a lot of guys, it's like now you're working with a complicated fraction. Just write 1 over the t is going to multiply everything in the denominator, just like that, from this concept of AB over C. So thus I can even expand it as 1 over distribute by t, which is outside of the bracket. We're going to distribute this part, okay? So if we multiply t times 1, that is t times minus 2t, that's minus 2t squared. Okay, so that is it. It is under parametric equations where you differentiate y with respect to x, but you do not have x on your final answer. It is under parametric equation. They have that concept. Our final answer, we do not have x. All right? On our final answer, we do not have x. It is like that. Anyways, let us see. So there are some of the other things. Okay, let me just, okay, is there anything that, okay, so these are the steps. Just need to find this, then substitute into your formula, or you can use another formula like I explained. Oh, sorry for that. Like I explained before, that there is another formula that we can actually use, which is one and the same thing. So that is it. Let me just have my answer here, because I'm going to need this one to answer the second question. So here we obtained 1 over t minus 2t squared. Okay, let's consider 1.22, which is the second derivative. Second derivative now. Y with respect to x. Okay. How can we obtain this? For this one, lucky enough, we have it in our formula sheet. Okay, if we go down, I think it's supposed to be page. Okay, guys, it's only that here. When I was removing these things, it's also removed the page numbers. But anyways, there's this part. It's supposed to be the last page. Supposed to be the last page. Okay, the last page here. So I'm going to explain this one according to your formula sheet. And some of us, we do not understand our formula sheet the way that it presented. That's the last formula. The last formula. The way that it presented this formula, some of us, we do not understand. This is the second derivative of y with respect to x, where x was given in terms of theta. X was given in terms of theta. Y also was given in terms of theta. So in our case, we are dealing with t. So we're just going to put t and put t here. Okay. But I want us to understand again what we are given here. It's d dt of this one, of this. Take note, the bracket there is saying differentiate with respect to t, this part, differentiate dy dx. The one that you differentiate, remember you have it. But after that, the resultant, multiply it to this one, multiply it to dt dx. Okay, no problem. Let me take our formula as it is. So that is the formula that we're going to need on that part. So like I said, the formula is stating that since we are having this with respect to t, it is saying the derivative with respect to t of dy dx of this one, let me write it down, dy dx. But that must be multiplied to the one that was written as d theta dx. Our theta is t, so it's dt dx. So I want us to understand here properly. Differentiate this one with respect to t, which we have. We have that one. We have it. So let us substitute this one, our dy dx. So that was going to be what? Let us substitute and differentiate properly. So it means the derivative with respect to t of this one, dy dx, which is the one that we got here as 1 over what? T minus 2t squared, like this, times whatever whatever that you're going to get after differentiating, multiply it to dt dx. Where is this one? It is from here, dx dt. Since dx dt is 1 minus 2t, it is the same as over 1. So if I want dt dx from these guys, I simply have to find what the inverse 1 over that. So it's 1 over 1 minus 2t from dx dt. Okay, so we have that value already. So we're just going to substitute 1 over what? 1 minus 2t, sorry, 1 minus 2t. So this is it. Knowing this, we are done. Because what you just need to do here is to differentiate the one that is with respect to t here. Differentiate this with respect to t. So we can differentiate it, guys. What are we having there? A fraction. We are back to our quotient rule. U over what? U over v. Remember our quotient rule. If y is equal to u over v, therefore the derivative of y there with respect to x, we're going to have v. All right, so this one we can write as v, the derivative of u, minus u, the derivative of v over what? V squared. So this is it. So meaning to say here, as we are differentiating with respect to t, we are going to have what? Our u, sorry, our v. This is the whole part representing our v, which is t minus 2t squared times the derivative of u. So u is what? It's 1. Its derivative, guys, u is equal to 1. So its derivative is what? That's a 0. Okay, that's it. So here we have got the derivative of what? Of u minus u. So we're going to need our u as it is our u. It's what? It's 1 times the derivative of v, our denominator, this one. So that's 1. T is going to give us 1 minus, we drop the power here. So it was going to give us 4t. Remember, we drop the power, then subtract 1. So that's 4t. Everything over what? V squared. Our v is the denominator, which is t minus 2t squared. But we must square it. We must square the v. So this is our v. We must square it. All right? So do not forget, guys, that there is what? There is this part here that we multiplied, which was from our dt dx. So do not forget to multiply by 1 over 1 minus 2t. So that's it. We have our derivative, but we must just simplify, guys. We are done. Yes, we are done. But let's just simplify. Let's just simplify this. So that is our second derivative of y with respect to x. Well, of y with respect to x is going to be equal to what? So here, guys, there is a bracket. The whole of this bracket here is multiplied to 0. So that is going to give us what? That is going to give us a 0 there. All right, so that's a 0. Minus 1. This is 1 here, so it's negative 1 times t. So guys, let me just get rid of this 0 there. So negative 1 times 1, that's negative 1. Negative 1 times negative 4, that was going to give us positive 4t. Okay? That's everything over this one, guys. Instead of us expanding, let us just leave it as it is. But it's going to be multiplied to this 1 minus 2t. So you can just write as 1 minus 2t times this bracket as it is t minus 2t squared. Okay? So that's the idea there. We're just gonna write this part as it is. All right, so in actual sense, there is no need of us factorize. There is no factorization part that we can have, no simplification that we're gonna have. So this is what we can say. our final answer was going to look like. So that is how they give us these questions. We just have to be careful in terms of how to answer the questions. Do not take a question as a simple question. There is no question that you can say this is a simple question. Attempt every question as a new question in terms of exam so that you won't have any mistakes. If you treat every question as a simple question, you are now bound to make mistakes or errors in your simplifications. So try by all means, concentrate on your questions, understand all the basics. So that is it, guys. Till we meet again.